Welcome to qnawire.
In this question, we are constructing a motion diagram for an object that starts from rest and speeds up, then has constant velocity, and then slows back down to a stop. And so a motion diagram is going to consist of dots for the position of the object, and then velocity vectors or velocity arrows at each point, and then we're also going to have delta V arrows between the velocity arrows. So the positions for an object speeding up are going to start off close together and then gradually get further apart, because speeding up, of course, means traveling a greater displacement each second than the second before. And then we're going to reach a point where we have constant velocity and our dots become equally spaced, because constant velocity means traveling the same displacement each time interval as the time interval before. In this case, we're going to call it 1 second. And then to slow down, excuse me, our dots are going to get progressively closer together, because slowing down means traveling less distance each second or each time interval than in the one before. And actually, I'm going to go ahead and pull maybe one more, a little bit closer. Okay. So I've used blue to represent my speeding up. And let me see, I think it was here that we're going to say, so here we have speed up. And then it was out to here that we had constant velocity. And then it was just for the last few dots that I had slowing down. Yeah. Okay. And so now we put a velocity arrow at each dot. And so our velocity arrows, I'm not going to label every one with velocity V because that's just going to get so cluttered. But what we want to show is that our velocity arrows get longer when we're speeding up. Our velocity arrows have the same length when we have constant velocity. And then our velocity arrows decrease in length when we have when we're slowing down, when we have a decreasing velocity. Have a little bit of trouble drawing that chevron, and then this last one's going to be super tiny because our final one is 0 velocity. So it's not going to change. There are some methods of making motion diagrams where you would actually connect your position dots with the velocity arrow, but that's not the way that was presented in this textbook. And then our final step is to show our delta V's, which go in between and slightly above. And I'm going to show a delta V pointing to the right to show our rightward velocities getting longer. There we go. And then I'm going to have a delta V that's 0 in the constant velocity portion. And then when we begin slowing down, we're going to have a delta V that again, and we'll just go ahead and label it delta V at each transition, And then when we get to the point where I said we're slowing down, we're going to put a delta V in the opposite direction. So we had rightward arrows for the velocity. The delta V is going to be a leftward arrow that helps our velocity shrink down over time to a stop.